Hey guys, and welcome back to another video on the channel. In today's video we're going to be solving this particular question. So this has been taken from an exam, student question submitted, and let's get straight into it. So the diagram shows the region R bounded by the curve y equals x to the lowercase r, where lowercase r is greater than or equal to 1, the x-axis and the tangent to the curve at the point 1, 1. So we can see we've got our tangent line, our curve here, and this is our region R. So it's enclosed wherever this pretty much is. Okay, I showed that the tangent to the curve at 1, 1 meets the x-axis at r minus 1 over r, comma 0. So pretty much we're showing that this coordinate here is pretty much this. So how would we pretty much show that? Well, we've got to find the equation of the tangent line pretty much, and then solve that for its x-intercept. So at this point here, we can see it's an instantaneous point, hence a tangent line. So what that means is we want the gradient of our curve at x equals 1. So in other words, we have y equals x to the r, and we want dy dx at x equals 1. So you've got to differentiate this. So dy dx, bring that r down the front, and subtract the power by 1 to give me this expression here. Now, this just gives you the general gradient at any point along this particular curve here. Oh, that's a terrible drawing, but you know what I mean. Along pretty much this curve here. But we want to add that specific point, so we're going to substitute in the x value straight away. So we go, alright, dy dx when x equals 1. So dy dx is r times by 1 to the power of r minus 1. Now, the cool thing about this is 1 to the power of r minus 1 is still going to be 1. No matter what this exponent is, it's going to be 1 because we've got to find that r is greater than 1. So there's no negative exponent there. So we know this will be 1. Whether it was 1,000, a million, doesn't really matter. So pretty much dy dx at x equals 1 is just r. So if our tangent line takes on the form y equals mx plus c, we know what that gradient is at that point there. It's r. So all we've got to do is substitute that in. So we go y equals rx plus c. Now, to find this plus c, we need a point on our curve, which we have right here. So when x equals 1, y also equals 1. So you can substitute that information into this equation here, but I'm just going to move this out this way now, because we don't need that anymore. So with this information here, substitute x equals 1, so you have 1 goes there, and y goes there. So 1 equals r times 1 plus c. So therefore c is going to be 1 minus r. So that means my equation of my tangent is this. So that's the equation of the tangent here, given this polynomial at x equals 1. Right, now we've got to find the x-intercept. So the x-intercept is when y equals 0. So x-intercept, substitute y equal to 0. So you're going to go 0 equals rx plus 1 minus r. And then you're going to rearrange to make x a subject. So you move the r across, so you have r equals rx plus 1. Move the 1 across as well, so r minus 1 equals rx. Then finally divide by r. And we can see we've matched our x coordinate straight away. So the coordinate to the x-intercept is indeed r minus 1 over r comma 0, because we substitute that y coordinate and it showed the first statement. So boom, you got 2 marks there. Okay. Let's see how much room we have for this second part. So that's all we really needed for the first part. Let's rub that out so we still have a clean diagram. Okay, so using the result from part 1 or otherwise, show the area of the region is this pretty much. Okay, so this region R we can express using integrals. So if we want to work out R, the best way to do it is to work out this whole area first under this curve here. So we agree, let's say that's just at 0 because that curve gets pretty close. So if we want just this blue region here, that is going to be the integral from 0 to whatever this x value is here, just 1. Okay, that would be the blue region. So if we want to work out this region in here, we're going to have the integral from 0 to whatever that value is, which we just worked out, was what's it called? Sorry, I lost myself for words there. We're going to work out this pretty much this entire region here, the blue region. So that would be the integral from pretty much 0 to 1 of x to the r dx. But you need to subtract this area here as well. So that would be the integral from whatever the x value is, which we worked out was this corner here. So this would be r minus 1 on r, to 1 of our tangent line here, which is rx plus 1 minus r dx. If you were to calculate this, this would give you the region r here. Okay. However, there's actually an easier way to calculate it rather than using the integrals. Now we'll still keep the first integral because that's still relevant, but this particular integral here is just corresponding with this area of this triangle here. Now this integral is going to be a bit hard to work out because we've got lots of r's and we'll get r squares and stuff. So an easier way to work it out is just work out the length of this side times by the height, which is 1, and then go area is a half times base times height. So what we want to do is, alright, that coordinate there we know is r minus 1 on r, and we know that coordinate is 1. So that means that length there is going to be 1 minus r minus 1 on r. Cool. So if I rub this stuff out now, because we don't need this anymore. The area of this triangle here, so area is going to be a half times the base. So the base is this here. This is the corresponding side length. So it goes a half times 1 minus r minus 1 all on r multiplied by 1. So just rearrange this. So we go area is a half. Now, if I want to combine these two together, they need to have common denominators. So what I'm going to do to the 1 out the front here is times the top and the bottom by r. So what we have is pretty much r on r minus r minus 1 on r. We can leave them times 1 now because that's still going to be the same. Now we can combine these two. So we have the area is a half of r minus r plus 1 all over r. So we can see here that cancels and that cancels because I distributed that negative, and that turned out to positive. So what we get is pretty much 1 over 2r for that pretty much region there, which is equivalent to this integral here. So what we can do is actually rub out that integral now because we don't no longer need it pretty much. So 1 over 2r pretty much, and that's it. Alright, so now we've got to integrate this guy. Now the reason why I didn't choose to do that big integral is because it's going to take a bloody long time. And it's much easier to do it this way. And in math, and if you're in a test, it's easier to do it the easy way and get the right answer than do it the hard way and have more likelihood of stuffing it up, if that makes sense. So now we just integrate this. So add 1 to the power, divide by that new power, and you have your bounds 0 and 1. Minus 1 on 2r. Substituting in the 1, we're going to get 1 to the power of r plus 1 over r plus 1 minus 0, still minus 1 on 2r. Now this is my region r, capital R still. Right, let's move it down. 1 to the power of anything is 1, so we have 1 on r plus 1 minus 1 on 2r is still equal to our big region r. Now let's try and combine these two. So we've got to give them like denominators. So what we're going to do is multiply pretty much this guy by 2r on 2r, and we're going to multiply this guy by r plus 1 and r plus 1. Technically we're multiplying them both by 1, so we can have a common denominator of 2r on r plus 1. And we can see that's starting to appear for our result here. So if we do that, we're going to get r is equal to 2r on r plus 1 minus r plus 1 on 2r on r plus 1. We can add them together because they're like denominators. So what we're going to get is pretty much 2. Now this negative is corresponding with this entire top bit. So 2r minus r minus 1 on 2r on r plus 1. We can see one of the r's is going to cancel. And what we're left with is r minus 1 on 2r on r plus 1 for our region R. Okay? Which is what they asked for there. Too easy. Now, so that's part 1 and part 2. You can see why you need the answer here for that particular part. But whether you use the triangle or you did that crazy integral, doesn't really matter. Righto, so now that we've got the expression for r, so r is r minus 1 on 2r on r plus 1. So our region R is going to vary depending on the degree of this polynomial pretty much. Okay, so 3, find the exact value of R for which the area of R is maximum. Okay, so pretty much we want the biggest area here. So what we're looking for is pretty much when R dash equals 0, because you're looking for a stationary point. And we're going to look if pretty much we're going to get probably 2 stationary points because we're going to have to use a quotient rule. We'll have to find r double dash as well. Okay, so if you sub in r double dash, and if you get a negative number, that's going to be a maximum, and if r double dash is positive, that is a minimum. So that's going to be important when determining the maximum minimum, because I have a feeling we're going to get 2 answers here when we do this bit here. So all we're going to do is differentiate this guy. So all we're going to do is pretty much use the quotient rule because we see it's a function divided by another function. So if you have a function u on v and you differentiate it, that is equivalent to v of u dash minus u v dash on v squared. Okay, so in this situation here, u is this guy here and v is this guy here. So in other words, we'll just label those. U is r minus 1 and v is, now I'm going to distribute these guys so I don't do a quote product rule again, so it will be 2r squared plus 2r. So if you don't know what I just did there, I just distributed the 2r to each of those components. Differentiating this guy, u dash with respect to r is going to be 1. Differentiating this guy with respect to r is going to be 4r plus 2. Now all we're going to do is literally plug into our formula. So v is 2r squared plus 2r multiplied by u dash, which is 1, so that would be multiplying by the whole thing, minus u, which is r minus 1, multiplied by v dash, which is 4r plus 2, all on v squared, which is going to be 2r squared plus 2r all squared. That is pretty much r dash. Okay. Now, if you're looking for a maximum point, you're looking when a stationary, pretty much for a stationary point. So you're pretty much looking for this scenario or this scenario. So in both scenarios, the first derivative is equal to 0. So the first thing to do is just set, alright, r dash is equal to 0. So what we're going to get is 0 equals pretty much all this straight away. Distributing the 1 just leaves it like that. Let's distribute this guy as well. So we have r times that, times that, times that, and times that. So we're going to have minus, I'm going to put a bracket because I'm going to multiply all this. So it'd be 4r squared plus 2r minus 4r minus 2. All on all this squared still. Now mind you, the denominator is going to disappear because I could multiply both sides by it and it would just vanish. So all I'm going to do is fix up the top really quick, distribute that negative sign to each of the components. So what we're going to get is, alright, 2 minus 4 is negative 2r. So what we're going to have is pretty much 2r squared plus 2r minus 4r squared plus 2r plus 2, all on all this stuff here pretty much. And that's still equal to 0. So if I want to solve for r still, well, I'm going to pretty much simplify this still. That will simplify to negative 2r squared. This will simplify to 4r and plus 2. So what we have is negative 2r squared plus 4r plus 2 on 2r squared plus 2r all squared equals 0. Alright, multiply both sides by 2r squared plus 2r all squared, and that disappears pretty much. So what we get is this little quadratic here, so negative 2r squared plus 4r plus 2 equals 0. Now, all I'm going to do is use the quadratic formula because I have a feeling we're going to get not pretty much nice numbers. Even if I divide by negative 2, I'm still going to get a quadratic with not nice solutions. So, a quadratic, if it's in the form like this, we can use the quadratic formula respectively. So, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all on 2a. So we can see straight away that's me a. We can see straight away that's my b. Now I do write capital B's because my lowercase b's look like 6's, so apologies for that. And all we got to do is substitute that information in here. So x is equal to negative 4 plus or minus the square root of, what was it, 4 squared minus 4 times negative 2 times by 2 divided by 2 times by negative 2. So we're going to get two answers here because the plus or minus sign. So now this isn't x, this is r, remember. I just use x because I copied it from here. This is actually r because that's that quadratic equation. So r is equal to minus 4 plus or minus square root. 4 squared is 16. And we're going to get another 16 here. So plus, because negative 4 times negative 2 is going to be 8 times by 2 is 16. So plus 16. All on negative 4. Right, let's simplify this. So r is negative 4 plus or minus 32 on negative 4. Okay, so now we've got to simplify this third pretty much. So if we think about it a bit, 32 is the same as, this is where the old maths comes in, 2 times by 16, and 16 is a square number. So if we wanted to, we could rewrite this guy like that. So if we did that really quickly, we'd have 2 times by 16. Now you can simplify this third here into two respective thirds. So then we'd get 4 square root of 2 for the square root of 32, pretty much. And if you put in your calculator, it would adjust to that as well. But that's how you do them without a calculator. So we have r is equal to negative 4 plus or minus 4 root 2 on negative 4. Now you can see I've got 4's here, so I'm going to divide by 4. So r is going to be pretty much positive 1. Now this is still going to be a plus or minus because remember there's two solutions there, so we can still write plus or minus square root of 2. Okay. So we've got two solutions there, which I thought we might have. So what this notation is pretty much saying is, alright, we have r is equal to 1 plus square root of 2, or r is equal to 1 minus the square root of 2. Now, one of these will minimize the area and one of these will maximize the area, because you can see the area r here is going to change respectively of the degree of this polynomial. And we've got 2 pretty much, and we want to maximize it. So this is where we get the second derivative involved. So where is our first derivative? The simplest version. Okay, here we go. So let's copy and paste this real quick. Copy and put it down here. So this was r dash. So now what we're going to do is we're going to differentiate this again, but I'm just going to change quickly how it looks. So r dash is equivalent to this statement here, negative 2r squared plus 4r plus 2 multiplied by this. And I'm going to bring this up here, so I use the product rule rather than the quotient rule. So this would be 2r squared plus 2r to the power of negative 2. So r double dash basically means, alright, differentiate the first term with respect to r, so this guy here. Leave the second term. Go to the side because I've run out of room. plus leave the first term, so negative 2r squared plus 4r plus 2, multiplied by the differential of that second term, which we missed straight away. Okay, so let's differentiate this. So r double dash, if we differentiate this, we're going to get minus 4r plus 4, still multiplied by this fella here. So now I'm going to move it on the bottom really quickly. So we'll have 2r squared plus 2r all squared, plus leave this first bit, so we have minus 2r squared plus 4r plus 2, leave it in brackets. Differentiating this guy, you bring the power down the front, subtract the power by 1, so we're going to have pretty much times by minus 2, 2r squared plus 2r, minus 1, which will be negative 3. Multiply now by the differential of this, which is 4r plus 2. We've done all that, all good. Right, so if we can simplify this a bit more, r double dash is going to be minus 4r plus 4 on 2r squared plus, that's not 4, that's 2, sorry. 2r all squared plus, now let's simplify this term here. So we've got this is a positive exponent, so that's still going to be on the top. So what we're going to have is minus 2r squared plus 4r plus 2. This is going to be on the top still because it's not a negative exponent, times by negative 2, so I'll chuck that at the front. We'll move that to a bit to the side because we've run out of room. Multiply by this term here, so 4r plus 2, all divided by this guy here, all cubed. Righto, so that's the second derivative. Now, we have two numbers pretty much. We've got little r is 1 plus square root of 2, or we have little r is 1 minus the square root of 2. Now, we're looking for a maximum, so in order to get a maximum, we have to have a negative number when we substitute one of these guys into here. Now, you're probably thinking, how are we going to do that? I'm going to use my calculator because that will just be ridiculous to sort out. I think this is a calculator question. If it isn't, then bloody hell. Okay, so I'm going to use my calculator quick. I'm just going to get the batteries. Actually, I can use the digital one. You probably won't be able to see it though. So we'll go write that down real quick. I didn't do this video pre-hand. I just did it just then. On 2r squared plus 2r squared plus. Right, write that down and shove that in the calculator pretty much. Okay, so if I go to the calculator and I go enter, so what was it? 1 plus the square root of 2. And what I want to do is substitute that in. So minus 4x plus 4 2x squared plus 2x all squared plus bracket negative 2 negative 2x squared plus 4x plus 2 bracket 4x plus 2 bracket on all this cubed, so 2x squared. If you don't know what I'm doing, I'm just plugging into my calculator on the computer very slowly because my other one's flat. Trace that, and then go trace, and then I want 1 plus, try the first one, see if we get a negative number. Okay, and then we go 1 minus square root of 2. Okay, so if we go 1 plus the square root of 2, gives us a negative value. So if you substitute this guy into this equation here, you're going to get a negative number, which indicates a maximum. So this is the R. This is the answer to question 3. Sorry that last bit took a bit. It's hard to record screen of the calculator at the moment with the software I'm using. But that is the answer to all these questions. I hope you enjoyed this video and you learned something. Yeah, I'll see you in the next one. If you want me to go through a question, just send me an email. It's in the channel information, I believe, or I'll link it in the description anyway. Alright, see you later.